In the previous video, we began our discussion on the diagnostic tools built in the TIA portal. This included tracing, monitoring, and watch and force tables. In this video, we're going to continue that discussion, and we'll get started by looking at cross-references. A cross-reference is when I can take a look at an object, wherever it is in my project, and see where else it's being used, or what's using it in my whole project. So to get started, let me open up my main routine. And if I'm interested in this tag here called foo, and I want to see where it's being used throughout my project, I can click on it, and then down here at the bottom I'll click info and cross-references, and here I'll get an overview of where it's being used throughout my PLC. So you'll see that here I got a column that says the point of use, and over here on the left is the object that contains it. So I can see that it's being used on network 1 in my main routine. I can click on this hyperlink, and that'll take me to the next point of use, which is here on network 6, and again on network 6 I'm using it in another place. Also, I'm using this in an entirely different function, and if I click on the hyperlink, it will take me to that function and again highlight where I'm using it. It's also important to note that we say here whether it's being read, like in this case it's only being read, or whether it's being written to in the column called access. And this is important. You want to be careful and make sure that your bits aren't being, say, written to in two different locations, because that could cause problems. Another way I can view my cross-reference information is, again, I can click on a tag and then click on this little X button up here. And this will bring me to a different view that serves the same purpose. I can drill down and see where it's being used in my code, and here my bit is only being used in one place, and that is what I clicked on. I also have a column here called uses. It's not really going to be relevant for tags, but if this is a function or a function block that uses other objects, like calls another function, that will show here. So if I click on, let's say, my speed control, and then click on my cross-reference button, if I go to uses, you'll see that it uses all these tags, those data blocks, and so forth. And I can see that that function is being called by my main routine and this organization block, main speed. Now, because in TIA Portal I can have both my HMI and my PLC in one project, you get a really nice advantage. So let me show you by opening up an HMI screen, and I'll open up that screen we made in an earlier video. And now what's neat is I can click on, say, one of my I/O fields, and down here at the bottom, so long as I have info and cross-references selected, I'll be able to see what tag uses that I/O field, for instance. This could also be, if it's another object, it may be multiple tags, and I'd get all that below. And not only do I get to see what screens in my HMI use this one tag, I also get to see wherever that tag is being used in my PLC program. So, for instance, right here, I'm on test screen, and within test screen, I can see that this tag, PB blue lamp, is only being used in one place, and that's IO field 3. If I go my other HMI screen, IO test screen, I can see that it's being used as a button when the button gets pressed. So if I click on this hyperlink, I'll see it's tied to this button, and then if that button gets pressed, then the light will turn on. Okay. And as I mentioned, the really nice feature is that I can see now where that tag is being used in my PLC code. So for instance, if I click here on my main, I can it will scroll me to where it's being used, and I can see it right there. So that's really nice. If something is goofy or displaying weird in my HMI, I can immediately go to where it's being written to in the PLC code. So a very nice feature. Now, I'm not just limited to interplay between the HMI and the PLC. I can also see where my tags come from. So for instance, here I have an input that I've selected, the push button green. And if I want to see what device that's tied to, I can right click on it, say go to, and then click on device view. Now this will launch the device view for the device that it's on, and it will highlight the module that brings that tag in. So here it's selected this digital input card in slot 1. And if I go to properties and then I/O tags, I can see that my push button here, push button green, is on the first channel in that input card. Okay, so if something were happening, if let's say that push button was flickering on and off and I did a trace and confirmed it, then that would indicate that there's a loose wire, and now I know where I need to go to fix the problem. Now, if I don't know where I/O device 1 is, I can click on this button here for accessible devices, do a search on my network, and now I can find the device here that matches the name of the device in my software. So this remote I/O rack is called I/O device 1. I'll find I/O device 1 here in my list, and then I can hit flash LEDs. And this will flash the 3 LEDs on my remote I/O rack. So if I don't know where this remote I/O rack is, all I need to do is look and find the one with the 3 flashing LEDs, and then I can go to slot 1 and go to channel 0 to fix the problem. And now if I want to work backwards, I can say click on the same I/O module, go to info and then cross references, and then I can see not only the tags that it's tied to, but also where those tags are used in my program. Next, let's look at some additional diagnostic tools built in the TIA portal. Now this will be for the PLC, so if I click on a PLC and then come up here to tools, I'm going to have all these different things that I can use to help diagnose problems. For instance, a big one is resources. I can see what my memory utilization is and what my processor utilization is for my PLC here. So things that will show up in red are bad, means that they are exceeding the limits or getting close to the limits, and things that are black are fine. Now up here you're going to see red and you're going to see a question mark next to load memory. Not to worry here, this just means that you need to select what type of memory card you're using within the 1500 PLC. So for instance here I am using a 24 megabyte card, so I can select that, and now I can see that my load memory, I'm only using 2% of that. If you were for some reason approaching this limit, then you would need to go to a bigger SD card for your PLC. Next, we got our code work memory and our data work memory, and these memory fields are internal to the PLC, so you can't expand them. If these were approaching the limits, like getting to 90% or higher, then that means that you might need to jump into a bigger PLC. I also have the same concept for my retained memory, and for if I'm doing motion control, what my motion control utilization is. Over here on the right, I have a nice little list that tells me what percentage of my I/O am I actually using. So here in my project, I've configured 162 points of digital inputs, but I'm only using 44 of those. And you can see that for your digital outputs, your analog in, and your analog out. Down here at the bottom, I can see how much each program or each data block is using memory-wise within my PLC. So if I see a data block that is through the roof and is killing my memory, then I might want to look at that data block and see if there's a way that I can trim up the data there. If I would like to get additional diagnostic information about the resources of my PLC, I can right-click on it and click on Online and Diagnostics. Now, if I look on the right, I got this task card called Online Tools. Here at the top, I can make sure it's in run mode or put it into stop mode, see if the error light or maintenance light is blinking. Over here, I get an indication of how my processor is holding up, and this is my cycle time. So right here, it shows 150 milliseconds. That is my watchdog timer that I set in the hardware configuration. And I can see what was the shortest cycle, what was the longest cycle, and what was the last cycle. Also down here at the bottom, I get an overview of my memory, and I can see how much of my memory is free for each of the different memory areas. So now I'll go back into my program info where my resources is, and you'll notice that I have these other tabs up here that can give me additional information about my PLC. The first one is the call structure tab, And what this does is this gives me an overview of how my code is structured. And this is similar to cross-references. What this will do is this will start with the programs that are called first, and those are going to be your organization blocks. So if you remember from my code structure video, I said that the organization blocks are where everything originates from. So looking at my main routine, I can click down on it and I can see now what my main routine calls. So I can see it calls function blocks, it uses these data blocks, and it also calls a function. And I can further drill down on that function and see that this in turn calls function blocks and functions and so forth. Now the reverse of that is the dependency structure, and that's where I can start with an object and see what calls it. So for instance, I can do this for data blocks and functions and function blocks. So if I go to, say, my boiler alarm function block, I can click on that and I can see it's being called by my main speed program and my main routine. Next, I have assignment list, and this is where I get an overview of all of the addresses used in my program. So here I'll have my first window, which will give me an overview of the inputs and the outputs. And if an input's being used, it will have a symbol on it. A diamond will represent a bit. More of a shaded area will represent something larger like a byte or an integer. If you want to get more information about how these are represented, you can click on this legend up here and it will tell you what they are. Now, if I hover over a particular point, it will tell me the tag name. So I can see RFID gate channel 1 is on address 22i22.0, and the next one, eStop channel 1, is on i22.1. Also, if I want to see where a particular address is tied to, all I need to do is hover over the address here on the left, and I can see in my tooltip the name of the module that it's tied to. So I know that these guys belong to my analog input card. If I go up here, I see that this belongs to my safety digital input. In the next window, I have an overview of my memory addresses, and this functions the same way. I can hover over, say, one of these bits, and I'll get the tag name associated with that bit. And the same thing, I can come over here, in this case, to a double word, and I can see the tag name associated with that. Now, TIA Portal does a pretty good job of, if I define a new tag, that it will move it to a memory space that's not being used. But still, that it will not prevent a user from overwriting a memory area if they wanted to or if they were being careless. The way that you can see if that's happening is if something like this occurs. So here I have my bits, but they're shaded in gray, and that indicates that there's a byte also associated with these series of bits. So you'd want to be careful if you saw that. Now this might be harmless, maybe it's just we're using that byte to copy over all these bits as one element and then sending it somewhere. But we could also be using a byte to write over all these bits. So let's take a look at this. If I hover over that symbol, I see that the tag name is bad byte with an angry face. So I might be suspicious about this. I can click here on that symbol, and down on info and cross references, now I can go and see where it's being used in my code. And here on axis, I see that it's writing. So I know that there's a point in the code where it is actually going to overwrite all these bits. Now that can still be a good thing, but it can also be a bad thing. So let's take a look at what's going on. And here you can see that in OB1, it's just automatically writing 0 to that whole byte, which will nullify all my bits there. So I probably don't want that to happen. So here I'm just going to delete this, and maybe if you see something like this, you'd want to ask someone about it. Next, if I come in here and I define a new tag, so I'll call this my new tag 2, and then hit define, you'll see that it drops me to a memory address that is freely available. And likewise, if I come in here and define a new byte, so I'll do a move command, and I'll just say my new byte. If I define that, it will take me again to a new byte area, and this will work for words and double words and so forth. And now if I go back into my memory overview, you'll see that these have been added. This is my new byte, and then over here is my new tag 2, and these are not overwriting a previous tag. So let's pause the video here. In the next video, we're going to complete this discussion on the diagnostic tools built into TIA Portal by looking at the simulate features for the PLC and for the HMI.